So let's go for this webinar, and thank you again to be with us today. We are very happy, as usual, to share this kind of moment with you. First slide, always with the safety first, the priority number one for the company. So please take care about all the psychological safety, about all the cybersecurity information. The speaker is me today, Clément Martinez. So you can take not my email if you have any question after the end of the webinar, or maybe if you need a specific demonstration, we will be very happy to make a specific demonstration for you. The summary today, quick introduction of Metrologic DCS, and we will see who we are, what is the manufacturing quality pack, the main topic of today, what challenge does the manufacturing quality pack address, and focus on the three modules, I would say. So first, deformation simulator and a demonstration, the machining corrector and demonstration again, and the last one, the decomposition analyzer and the demonstration at the end. And we will finish by a Q&A session. So what is the mission of Metrologic DCS? The mission of Metrologic DCS is to develop and deploy innovative and universal 3D metrology solution built for the manufacturing excellence. And maybe you don't know it, but we merged with DCS a few months ago to offer our customer to a complete solution for tolerances and assembly optimization to an advanced analyze will keep our core of business, the 3D metrology inspection solution. So reminder now, our new color is blue for Metrologic DCS. About us, so at Metrologic DCS, we want to close the loop between the design, the manufacturing, and the inspection. So don't be surprised. Again, our new branding is blue, and today we have more than 45 years of experience, and we can assist you with your project from the simplest to the most complex project. We are based in Grenoble in France, but also in Troy in Michigan in the US. And every day we try to help you. We provide a specific solution in your inspection lab, on your production floor, and in all the design department to improve the precision and to give you the possibility to keep the full control of the quality process. We are part of Sandvik Group. Sandvik Group is a Swedish company and one of the leaders in advanced manufacturing technologies, material solution, and industrial tools. Metrologic DCS is everywhere. We have different resellers, various offices in Europe, in Italy, in Germany, France, Spain, but also in the US, in Asia, and in South America, for example. So today, Metrolog DCS is a product. The product is available in more than 20 languages and used in more than 60 countries. We are proud of the big values of the company. So the curiosity, the responsibility, and always be customer focused. So about the customer care, we're delivering 2 major releases each year with a specific development and test team. We provide a big support through our hotline team, training team, and we have a specific team for your custom project. And we also offer CMM maintenance and retrofit services for long performance and reliability of all your device and all your CMMs. Our solution, software solution, are designed for all the industry, including, of course, first automotive, aerospace, and defense, but also maybe a specific market like medical devices or luxury watchmaking. You can find some information about our key account, active user, with today more than 7,500 active users, and we are universal, so we can connect Metrolog to different interface or devices. Last slide about the company. So you can discover our universal software suite first with 3DCS to define and optimize all the tolerances, planner to prepare your work, prepare your report, and then Sigma to create your program offline and avoid any collision with the digital twins. Then use Metrolog. So you have to with Metrolog you are connected to the real CMM and run your control and your inspection to analyze and correct in real time. And at the end of the process, QDM for an advanced analysis of all your data. So focus on the topic of today, the manufacturing quality pack. So what is the manufacturing quality pack? The module manufacturing quality pack connects the three steps that have always been disconnected until today. And we want to close the loop between the measurement and machining. So we have today three different capabilities. First one, the deformation simulator to anticipate the deformation before you cut the first part. For example, you test what can go wrong and anticipate the deformation. And we will focus on it just after on the next slide. Second one is the machining corrector to correct machining issue faster. When you measure a deviation, for example, you get an exact correction, not a guess, thanks to the machining corrector. Like the deformation simulator, we will focus on it on the next slide with a specific demonstration. And then the decomposition analyzer to understand deviation clearly. So sometimes you have the deviation, but you don't understand why. You don't understand if it's default of position, maybe default of size, orientation, or just shape. So you will understand that with the manufacturing quality pack. Next slide, and what challenge does the manufacturing quality pack address? Today we have three departments, three tools of the design, the machining, the quality, and they are not connected between themselves. When the teams doesn't share data or context, correction become guesswork, and no one has the full pictures of the result, and correction are based on speculation and not on facts. And all the deviations are incorrectly interpreted because the team member lack visibility into what happened before or after. As a result, it takes too many iterations before the first production and a stable state. The consequences are real. Time is wasted, money is lost, a lot of scrap, and the teams become frustrated. This is exactly the challenge that the manufacturing quality pack is designed to address. Next slide, and first capability with the deformation simulator. And this role is to anticipate and confirm tolerance robustness before machining begins. So next slide, and what is the challenge today? So today you define your tolerances, plan your machining strategy, and then you wait. So the first part comes of the machine, deviations show up, and the loop begins, I would say. So you measure your part, adjust, and try again. That cycle costs time, money, materials, and you don't wait to pay for. So what is the root cause? The tolerance strategy was never validated before production start, and the shop floor became the test bench. That's exactly the problem deformation simulator solves. Next slide, and what we can do with the deformation simulator. So if you know the default of your CNC machine, you can anticipate it and create the simulate default on the CAD model on Metrolog. You can generate default in size, position, orientation, or shape. So you are free to manage as you want the default and adjust it at any time. Now, when the default is done, so you can generate some default on some surfaces of your CAD model, you can generate measurement data. Maybe you can use a retrieve, for example, or the probing. And at the end, you can validate your design tolerances strategy. So you can imagine, for example, the datum A with a big default and all the consequences on all the GD&T in connection with this datum. So maybe you have to adjust some tolerances, try to reduce the tolerances to optimize the process. Now you will understand better with a quick demonstration.
Our goal is to simulate defects on our part, for example, to validate the robustness of our tolerances, or to anticipate defects in the machining process so we can determine in advance what corrective measures to apply. To do this, go to the Metrolog deformation module and select the surfaces to be deformed. A wide range of deformation options is available to us. The deformation amplitude, the defect offset, as well as the ability to choose which translation and rotation to apply. In short, you have full control over everything. Use the calculator for a preview. Adjust further if necessary. Once you're satisfied with the defect you've created, confirm by clicking OK. It will appear in a database but remains editable if needed. Change the color of this deformation or hide it if necessary. The next step is to generate a point cloud of the deformed surfaces. The surfaces that remain unaffected will be perfect. You can select the point density and click OK. The point cloud appears instantly. Then, with a quick analysis using the plan collector inspection, we can measure this reference to see what defects it would have in real life. The result appears in the results window. In our case, flatness, which is our reference A, shows a deviation of 0.368. Now let's see how this affects another tolerance. Take, for example, this surface profile, which has no defect but depends on reference A, which has a significant defect. Metrolog evaluates the tolerance feature as well as the other references B and C. The calculation of B and C allows for an update of the GDTs from our element database. All GDTs that use reference A are significantly impacted with large deviations. This module therefore allows us to see whether our reference system needs to be adjusted or not, and enables us, for example, to anticipate machine defects so we know how to respond using the module we will now look at, the machining corrector.
Next slide, and new capabilities with the machining corrector. So what is the challenge today? In most machining shops today, when a CNC machine produces a part that is not quick right, the operator has to make a correction manually. And the processus looks like this. So the first part is produced and measured. And when you have deviation, maybe on shape or position, someone has to adjust the machining offset. And this adjustment is based on their experiences or intuition, but not on real data. So they have to try again and again and again. And this is the challenge we want to solve with the machining corrector. Next slide on the machining corrector and what we can do with it. So machining corrector is a tool for calculating machining tool correction by integrating machining operation into Metrolog. And when we talk about it, we talk about planar facing operation, shouldering and facing operation, drilling operation. So every correction is calculated from inspection data, not guesswork, no manual estimation. And we choose the kind of operation to apply. On each axis applies the operation, and the job is done. So, and of course, you can repeat it for each operation necessary. And to go further, and this is one of the game changer of this manufacturing quality pack, the predictive mode computes what the next part will measure after correction before running it. So you have a global overview thanks to the scan GD&T About the next part, if you apply all the tool correction create and generate before. And you have also the possibility to import matching files operation from Metrolog or CAM software. Next slide about the matching corrector and how it works. So the first step is for the design department and generate a new part thanks to a CAD or CAM software and send it to the CNC machine. We have the first part in red, and the next step, as you know, is to measure this part to check if it's okay or not. So thanks to the CMM and Metrolog, we can say, okay, the first part is bad. We have some default, but we can generate the tool corrector thanks to machining corrector and the manufacturing quality pack. So all the information, all the tool correctors are sent to the CNC machine for the part number 2. The part number 2 is generate, and the next step is to measure this part always with Metrolog. And this time, thanks to the tool corrector generated by machining corrector, the part number 2 is green. So it's all the JD&T are on the tolerances. And you can use the tool corrector for the part number 2 with Metrolog for the production step and to keep all the part on the good tolerances. Now it's time for the demonstration of the machining corrector.
After the first inspection, this part has some defects. Some dimensions are within tolerance, while others are out of tolerance. Let's use the machining corrector module to calculate the corrections to apply to our second part. Let's focus on the first machining operation for our top surface. From the machining corrector menu, I click on my CAD model that corresponds to the surface to be machined. Next, I select the part reference and the type of machining operation. In our case, based on the domain expert's guidance, I know this is a planar facing operation. All that's left is to choose the tool reference, then select the degrees of freedom to apply. In our case, we'll simply adjust the length of our tool. I click OK, and from the machining phase window, where all my machining phases will be stored, I see the correction I need to apply. 0.200 millimeters to my tool length. Now let's focus on references A and D. Same principle. I select the reference part and my operation type. To do everything at once, I select shouldering and facing. I always apply my tool datum and degrees of freedom. I can even recall the value of my previous offset for greater consistency. The second machining operation appears below the first. There you can see the offsets to be applied. For reference C and wave-shaped surfaces, the same approach applies. The only factors to consider are the change in reference point and tool positioning. We're still performing a shouldering and facing operation. Working closely with the machinist, I specify which axis the machine should operate on. My third operation is complete A, with the corrections to be applied to TX, TY, TZ, and the diameter of my tool. For our final shouldering and facing operation, we'll select the purple surfaces. We'll need to change the reference part because we're switching faces, as well as the tool reference. For the rest, I'll select the degrees of freedom to apply. Why you're starting to get the hang of the process now. I only have one more operation left to do from here on out. The last operation for my through-hole drilling isn't relevant because I'm switching to a different type of machining operation. This time, I'll need a through drilling operation. I'll check the offsets to apply and select the axes on which my machine will apply these corrections. It's over. All my machining operations have been created. I'm going to use predictive mode to identify any defects in my next part. As you may know, Scan GDT provides us with an overview of our GDTs, their statuses, and any out-of-tolerance elements. But we can go a step further and predict the future measurements of machine part number 2 if we apply these corrections. A clear table shows me their future statuses, as well as the improvement achieved compared to the initial defects measured on the CMM. These predictive measurements can also be verified using our detailed views. To see a comparison between the current part that has just been machined and measured and the future part that will be machined with the corrections, you can see a significant improvement with deviation points within the tolerances. This module helps you save time in understanding which corrections to apply, allowing you to avoid excessive scrap. Now you can produce with confidence. All you need to do is export these results in CSV format, for example, and import them into your machining center.
Next slide. And new capabilities now on the decomposition analyzer. And the role is to understand. Understand because sometimes we have some deviation, but we don't know if it's default on form, size, orientation, and position. But now, thanks to these capabilities, it's time to have a clear diagnostic. Next slide, and what is the challenge today with the deformation analyzer? So when a part fails inspection, we can clearly see the deviation, as you know, with all the results, but we don't always know that cause it. At that stage, it's often difficult to determine the issue, come from maybe the shape, maybe the size, maybe the position, or the orientation. As a result, non-conformance reports usually describe what is wrong, but they don't explain why it happened. At the end, a lot of meeting without clear decision to apply, so you lost a lot of time again. But the challenge is not today to detecting the deviation, but to understand its origin. So what we can do now with the decomposition analyzer? With the decomposition analyzer, we are able to understand every deviation in one click. So is it position, is it orientation, maybe size, maybe shape? It's clear in one click. So thanks to the decomposition analyzer, it's easy to understand the key parameters that need to be correct in production and monitor them. So your traceability is simplified and you save a lot of time with clear information for share with your teams and customers. So now, as usual, a quick demonstration with the decomposition analyzer.
Today we have hundreds of results available, some of which have varying degrees of defects. But do you know how they behave? The decomposition analyzer function allows you to quickly determine whether the defect is related to shape, size, position, or orientation. While the overall distribution is displayed by default, you can also calculate the results by defect type. The label is then automatically updated. These defects are also visible in our results window. A clear and quick understanding of your defects. Results displayed directly on the part geometry inside Metrolog. No separate report to cross-reference. The perfect tool for a faster corrective action. You know what type of deviation you're dealing with before the root cause meeting even starts.